So lesson 1-1, as I said, it jumps us right into Algebra 2 with this book. It does not ease us in at all. We jumping in. Some of this stuff is stuff I've taught more mid-year in Algebra 2 in the past, but I'm going to walk you through it and we'll see what we can do. A little bit of an introduction here as we talk about functions. A diver is going through ocean search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. So my graph's a little blurry, but it's in color. Yours copying a little dark, so it's a little bit hard to see in some pieces, isn't it? So kind of work between the two. Sorry, not the best to get us started, but so there's some questions, and I don't necessarily know how much of these answers I'm going to write down here, but, you know, feel free to write down what you want. As we look at that graph, first question to consider. What details can you determine about the dive from the coordinates of the point 5, -8? Thoughts there? If you think about the ordered pair 5, -8, but in the sense of that graph, what's that representing? What's that saying? What do you think, Landon?
It took her 5 seconds to go 8 feet deep.
Okay. Agreeable?
Yes.
Okay. So 5 seconds into her dive, she went 8 feet deep. And what about that 8 feet deep? Deepest she went? Okay. If I throw in a mathematical word, it's her minimum value because it's the lowest point on the graph. If we, you know, start thinking about in terms of graphs there. Okay. So, and there's not a whole lot of room to write. Feel free to write that down. I'm not going to necessarily write it into there. We've talked about it, but well, I probably should, shouldn't I? I'm going to say at 5 seconds, the diver was 8 feet deep. Just because I don't have a lot of room to write there, you guys can probably write smaller in pencil. And I'm going to say that is the lowest point. Interesting. You said it was a she. I think I said he earlier to myself, so. But it tells us, you know. Okay, so write down, you know, again, this is just kind of getting us into the train of thinking about features of graphs. I already threw in the word minimum, that is a minimum point there. Okay, so B, average speed. What is the average speed of the diver in the water? How can you tell from the graph? When we talk about speeds, what kind of labels do we usually put on speeds?
Miles per hour.
Right. When you're driving your car down the road, you think miles per hour, right?
Yep.
Okay. Well, we're not talking miles per hour with this diver.
Seconds per feet.
Reverse it, feet per second, right? When we're doing speeds, we're always going to put the distance over the time. So what is the average speed in feet per second of this diver? And how can you tell from the graph? Thoughts of how we find the diver's speed? Yeah, thought, Eileen?
I'm not quite sure how to explain it. Like, I could explain it in German. So you put the -8 on top, put a dividing line and a 5 seconds underneath, and then you can shorten it, divide it by 5 maybe. Then you have a smaller number.
Okay, and I almost agree, except look at the starting location. So, okay, so right here, she's saying, okay, 8 feet per 5 seconds, right? And you could divide that out, make that, you know, but if we're going to talk that way, we have to think about the starting point there. Gatlin? It starts with a 2, right? As opposed to starting at 0, 0.
It'd be 10.
Yeah. If it started at 0, 0, I'd be right with you. You know, you're doing the right thing there because it's an 8 feet change over 5 second change. Okay. What were you going to say, Caitlin?
I was going to say that you can just follow the graph and subtract. So she starts at 2, and then in 1 second she travels to 0. So that's 2 feet in the 1 second. And then if you look at 2, she goes from 0 to -2 in the next second. So you can see that she moves 2 feet per second.
Okay. One way or another, we're all going to come up with 2 feet per second. Now, there's not just one way to do this. What math concept are we using here?
Algebra. Algebra 2.
Okay. Technically, no, we're using algebra 1 or pre-algebra even. What's the word? We're finding something of this line. We're finding slope, aren't we? Okay. We're finding slope. So, the idea here, Caitlin was looking at, okay, right here, we go down 2 feet in the process of 1 second. That's the idea of what Caitlin was looking at, right? And you can do that. My purple's not going to show up there on the blue, is it? You can do that repeatedly. Down 2 feet over 1 second. And so if we think slope, rise over run, that is 2 feet per 1 second. Now, when Eileen was talking about doing the 8 over the 5, the key is you have to think about we're not coming from 0, 0, we're coming from 0, 2. And so you could think in terms of, what do I want to say there? Y minus y over x minus x as well. Okay? So I'm just going to throw in, basically think slope. Okay? Now, I will say, technically, if we look at this line, we're going down 2 feet over 1 second. Technically, this is a negative slope, but the speed is still 2 feet per second. Okay? So C, which point on the graph shows the starting location of the diver? We kind of already mentioned that, didn't we? Where's my starting location of this diver?
2 feet.
Yeah. This diver starts 2 feet, what? Above water, right? In other words, they're saying the diver starts from the boat. The boat is 2 feet above water, so the point 0.02 is where we're starting, and that's basically saying that at 0 seconds into her dive, she is, now I'm saying she too, the diver is 2 feet above water. Okay? So that is at 0 seconds. Diver is 2 feet above water. Okay. Okay, and D. What does the V shape of the graph tell you about the dive? And what does it not tell you about the dive? What do we know this diver did? We know, based on our starting point, our low point, and our ending area, that the diver went what? Down and came back up. Okay. In a total of 9 seconds. Okay. What do we not know? We don't know why. We don't know what the diver was diving for. Okay. I'll take it. Valid answer. Okay. Do we know, was this the exact path? Did the diver do exactly this V?
No.
Straight down and then straight back up just like that?
No.
Not necessarily. We don't know that. Okay. This graph is more representing starting location or lower location and the ending. Okay. It's not really representing, maybe did the diver end up going horizontal at some point? I mean, most of you guys have probably swam, right? Is it easy to just dive straight down? Sometimes yes, sometimes no, right? Okay, so you got your brains thinking about graphs here?
Yeah.
Okay. Aaron's back there swimming. Okay. Swimming through the classroom. Okay, I have several vocabulary words I'm going to throw at you today. We're going to talk domain and range. We're going to talk intercepts. We're going to talk increasing, decreasing, positive, negative. Lots of pieces about the graph. Okay? Now, domain and range. Old news?
Yeah.
Yeah. Without necessarily reading mine, when I say domain and range, what do you guys think? Maybe hard to do because you've probably already read mine, but domain and range, what do you think? Because I don't have up there one of the things that I think. What about the domain values? It says the set of all possible inputs for a relation. What do we usually think besides that? Domain values are my X values, right? Yeah, that's old news. If it's not old news, we're trying to remember it. And if domain is the input, so the X's we're putting in, range is the set of all possible outputs, and those are the Y values. Sounds familiar, right? Even if you didn't come up with on your own, you're like, oh yeah, I've heard that. You've been hearing that since middle school at least. So, okay, so we're going to talk about domain and range on the next page and actually do some examples, but a couple of things. Set notation. You are somewhat familiar with set notation in that you know how to write inequalities, right? When this book talks about set notation, it's talking about writing it with an inequality. Okay. Now, when you look at the homework, of course, it's like a math Excel variation on the homework, so I don't get to put my own wording in. So I have to throw in set notation. But set notation, these are inequalities over here, right? These are inequalities. These are what you're used to. The set notation is that there's this X out front, and what this reads is X such that, and then this is the part you're used to, isn't it? 3 less than or equal to X less than or equal to 4. But set notation always has this X out front with a bar, and that reads X such that, and then the rest of the statement. Okay, so, and maybe if you even want to, this is X such that, and then you read the rest. Okay, so just so you've heard the vocabulary a little bit. We're also going to talk about interval notation. And interval notation is something that I've sometimes introduced in Algebra 2, but with the newer standards, I definitely want it in Algebra 2. I'm guessing you're not familiar with interval notation, unless it's something that Mrs. Rogers has started introducing lately, but you're probably not familiar with interval notation, so that's going to be new to us. But interval notation, it's a way to rewrite inequalities, but instead of using the less than, greater than symbols, because when I say inequalities, what am I meaning? Less than, greater than, less than equal to, greater than equal to, right? So interval notation instead uses parentheses and brackets. So that's this chart here. So we're going to use parentheses, brackets, and inequality signs. Okay, now, this is a chart that honestly just came straight from your book. Okay. I took off the online book, kind of like that graph up above. When I blew it up, then it kind of became fuzzy. But you guys can read it, right? It's not quite as nice as I'd hoped. You know, it looked a lot better on my computer screen than before I printed it. So, but let's look at some of these just to get you guys an idea. And so, if the words say all real numbers that are greater than or equal to 3 and less than or equal to 4. Well, here's the inequality. Greater than or equal to 3, less than or equal to 4. Do you see your less than or equal to 4 part over here? Yeah. Where's the greater than or equal to 3 part? That's that piece right there. And they're combined into that compound inequality. You would have worked with these compound inequalities back in Algebra 1. However, that was also, what, 2 years ago, right? Or I don't know, maybe it's all fresh in your mind. But that's your set notation because that's taking X less than or equal to 4, and it's also taking x greater than or equal to 3. It's taking those two pieces right there and combining them into one where x is in the middle. And so that's taking the x and 3 and flipping them, which the sign means gets flipped also. So this is that with inequalities, with set notation. Now, I just had a thought. How confident are we with which sign is less than and which sign is greater than? Are we confident or are we not confident? Anyone need a cheat sheet on their paper? Which sign is that? If you're someone out there saying, yeah, I'm not confident, Mrs. Sargent, and you're too afraid to tell me, well, here you go. There's your cheat sheet. That is your less than sign. I know, it's an alligator, right? Eating the bigger number. But it's hard to think alligators when we use letters also. So it's a less than sign. My trick is I say, okay, a less than sign, it looks like an L. If I make an L, and I get sloppy with my L, doesn't my sloppy L turn into a less than sign real quick? It does. So that's always my key, as opposed to alligators were great in elementary. It's kind of hard to think about alligators now because we're not always eating numbers. So if this is less than, that means this sign is greater than. Okay, so if you need that cheat sheet of which sign is which, write it down. What happens when I put the little line under them? Or equal to, yes? And so, I know I should probably throw this in here. This is now less than or equal to. Sorry, doing this on the fly. I didn't think about a place to put this information. So hopefully you're finding room on your notes. Greater than sign with a line under it is greater than or equal to. Okay, so that's kind of your little cheat sheet of symbols there. Okay, interval notation. If this is all numbers that are greater than or equal to 3, less than or equal to 4, your interval notation is 3 to 4. And let's see. I didn't think about a good way to show this. Let me throw in a, well, not a good spot, but you guys can see it on here. If I throw in a graph here real quick. Okay. Where is all numbers that are greater than or equal to 3? Where are those numbers in relation to 3? They're where?
Right.
To the right, aren't they? Where are all numbers that are less than or equal to 4? To the left. So where are these numbers that are greater than or equal to 3 and less than or equal to 4? They are where? They're in the middle. Okay? If you remember anything from Algebra 1, this is an and statement. Now, with that in mind, because it says equal to, they use brackets. It would be equivalent to, what did you guys use in Algebra 1? Did you use filled in dots?
Yeah.
Right? You used filled in dots if it was equal to. If it wasn't equal to, what'd you use? Not filled in dots, what we call open circles, open dots, whatever. Okay, so with interval notation, it's taking this interval. Where is my shading? My shading goes from 3 to 4, and then it has brackets on either side because it was equal to. Okay, if we look at this one, what's different here? All real numbers that are greater than 3 and less than or equal to 4. What changes over here? Just one thing, right? Instead of less than 3, it's less than or equal to 3, or reverse what I just said. Instead of less than or equal to 3, it's just less than 3. Now, what do you notice changes in the interval notation? It's a parenthesis. So the idea is the brackets go with the closed circles. Whereas a parenthesis, I don't know, this is getting kind of messy. I didn't think about how much information I wanted to throw in here, and it's turning into more than I planned. So this is still shading between 3 and 4. It's still greater than or equal to 4, so it's still like having a closed circle there. At 3, it's just less than 3. So in Algebra 1, you did an open circle. When we talk interval notation, they're going to use a parenthesis. Okay, so the shading my interval here, where's my graph at? It starts at 3, it ends at 4. Okay, I'm just trying to get you some of the information so as we go into my next pages, because we'll talk about this throughout the lesson, as we go into the next pages, some of this will make a little sense. Okay? And first lesson I've taught out of this book. May want to revamp how I do this in the future, but when you're teaching it to yourself, or I'm writing the notes, I don't always think, I should have done something differently here, but oh well. So what's different here? All real numbers that are greater than or equal to 3 and less than 4. It's just a matter of where the equal to sign is, right? That interval is still 3 to 4. The bracket is with the equal sign. Parenthesis is with the non-equal sign. This one here, neither of the pieces are equal, so all real numbers that are greater than 3, less than 4. So the interval is 3 to 4. Now, all real numbers greater than or equal to 3. Go back to the basics. If I say all real numbers greater than or equal to 3, what would you write? Not what's written here, not what's written here. What would you write? We'd probably start with an variable. So if I say x, if it's all real numbers greater than or equal to 3, you start with x and then you say what? Greater than or equal to 3. Is that the inequality you know? I hope. That should be old news. Okay? Now, with that in mind, see, I don't like how they did this. Because what they did, I don't know that I saw this in homework. What they did with set notation, and I'm not crazy about, what I would say for this with set notation is I would say it's x such that x is greater than or equal to 3. Or again, I'm concerned about this piece right here. Can you write x greater than or equal to 3? Okay, what they did is they flipped it and said 3 less than or equal to x less than infinity, because x greater than or equal to 3. What's that graph look like? I don't have space to put this. If we're graphing x greater than or equal to 3, where is that? To the right, yes? So, if it's going off to the right here, it's starting at 3 and going to the right. Where is it going when it goes to the right? It's just going. Where does it end? It doesn't. I heard something over here somewhere. It's going where?
Infinity and beyond.
Infinity and beyond. Okay. I feel like it's Toy Story here. We're going to infinity, right? So right there, notice this is an equal to. So it starts with a bracket. Notice it's going from 3 over here to infinity. And that's why my interval notation is 3 to infinity. Okay, because the graph, it's x greater than or equal to 3. It starts at 3 and it keeps going on forever. There's no stopping point. So you have a bracket there on the 3. Infinities always use parentheses. So just kind of beware there. This one is reversed. All real numbers less than or equal to 3. I would, for that one, say x less than or equal to 3. So I would say that part right there is the part you need to be familiar with. Why does this interval start with negative infinity? Can you visualize that? Where's my graph going? It's going left, isn't it? And so, where can I even put this? Oh my gosh. Okay, plan differently next time. So if it's going left, it's not going to positive infinity. It's going to negative infinity. Okay, so this is represented by negative infinity. So thus, when you read the interval, it goes from negative infinity to 3. And then if you see the phrase all real numbers, what do we mean all real numbers? Mean everything, right? Where do all real numbers start? Where do they end? And so the interval notation for that is negative infinity to positive infinity. They use the same thing here. I honestly have just seen this sometimes that it'll just say x is a real number. Okay? So I know I've kind of made a mess of this. Use this chart to refer to. Okay? You've got some inequality information and set notation. You've got some interval notation. Use this chart to refer to, which is why I put it in your notes. Now, let's go to the next page. Let's talk domain and range. Now, I'll be honest. I was nice. I provided the graphs in homework when I was setting up the homework the other night. Sometimes the homework was nice and provided the graphs. Sometimes the homework was not as helpful and didn't provide the graphs. Do you know what the graphs of each of these look like if I didn't put them here?
No.
Yeah.
Some yes, some no, yes? Some of these I would think you should have an idea of. Like, if I say, okay, forget the minus 3. If I say y equals x squared. Dig deep, guys. Go back to that Algebra 1, I know, 2 years ago. But do you remember y equals x squared being a, what's that word? What? Parabola. Right? That's a parabola. That U shape is a parabola. Those are the basics we have to learn. Or we have to, not learn. You've learned it. We have to remember. Okay? So we're going to talk, let me go through some domain and range here, then I might have you pull up Desmos, because Desmos is a really easy way. It's just a website you can go to, and you can type in whatever graph you want. So if you don't know what a graph looks like, if they give you a graph on homework, can you open a Desmos tab and type in the graph and see what it looks like? Right? Okay, so let's talk about domain and range here, and I'll talk about Desmos here in a little bit, because I don't want to get the iPads out and get us too sidetracked. Okay, so we have a graph of y equals x squared minus 3. We're first going to talk about domain. Okay, think back to the front page. What was domain? X values, inputs. Okay. Where are my x values on a graph? Left to right, yes, because here is my x-axis and here is my y-axis. So my domain values, my x's, go left to right. Now, based on the fact this is a parabola, how far left do you think it's going to go? And how far right do you think it's going to go? Does it stop here just because this graph stops here? No. Realize I took a screenshot of that certain piece. This technically, if I'm going to draw a good graph, I should technically have arrows on there. Okay, I didn't think to put on the computer. So this graph, it's going to keep going up, and as it keeps going up, it's going to go wider and wider, wider, right? Does it ever stop getting wider? No. So this graph is going to go infinitely left and infinitely right. So a couple of different ways we can write this. If we use the, I wrote that kind of big. Now, this symbol I'm doing here is a brace. It's that squiggly, funky squiggly parentheses thing. But one way you could write it, x such that x is a real number. And that's kind of the long way of saying all real numbers. Okay? We can't write an inequality here. And I don't remember exactly how the assignment had us input it, which is why I'm trying to cover several bases. But it's all real numbers. That's what I want you to think here. All real numbers, depending on how you have to put it. What is that interval notation? So interval notation being this side, right? What is all real numbers in interval notation? Negative infinity, positive infinity, right? Because what is my graph doing? To the left, it's going to negative infinity. To the right, it's going to positive infinity. So the other way to write my domain is saying negative infinity to positive infinity. The homework used a little bit of each, which is why I'm trying to prepare you. You'll have to let me know later how well I succeed. Hoping I prepare you, otherwise the homework could be a total disaster, but we'll figure it out. Range. Okay, so domain were the x's, right? Range is the y's. Where do y's go? Up and down. So, how low do I go?
-3.
This point right here is -3. Does my graph ever go below -3?
No.
No. Okay, so my graph starts at -3 for the range. How high does it go? It goes up and up forever. Does it stop?
No.
No. So, you just wrote interval notation, technically. Interval notation, where did it start? -3. Where did it end? Infinity. Now, infinity always uses parentheses. With domain and range. Does this graph touch -3? Yeah. So we're going to say this is a bracket. Now, what is the inequality for this? My y values, y because it's range, my y values they started at -3 and went where? Up. What's the word when we talk inequalities? Greater than. So for your inequality, it would be, officially if I do set notation, y such that y is greater than or equal to -3. I'm putting both. You might see inequalities in homework. You might see interval notation in homework. So I'm trying to prepare you for both. Okay. That wasn't horrible. I saw some recognition out there when we were talking about that. Yes?
Sure.
Sure? We'll play along, Mrs. Sargent. We'll tell you sure. We'll figure it out. Okay. We'll figure it out when it comes homework time. Okay. Let's look at this one. So this is an x squared graph. An x squared graph is always a parabola, the U shape. What's this? Absolute value. Absolute value bars? Guess what kind of graph that always is? Not a U, but a V. Okay. This was a parabola that was shifted down 3. This is an absolute value V that went right 4. And here's what I'll tell you. If it's plus or minus outside the piece, it goes the direction you expect. Okay, so this went down 3. If the plus or minus is with the x, in this case inside the absolute value, you go opposite the sign. So that's why it went right 4. Again, I'm going to encourage you to use Desmos right now since we don't really know these graphs. Okay? So let's talk domain. Do you have thoughts on the domain? Again, domain are my x's. Here's my x-axis. Here's my y-axis. How far? Which way? Which direction are my x's going?
Up. To the left.
We're talking left and right. How far left does this V go? Yeah, does it keep going even though the arrows aren't there? Yeah. How far right does my graph go? Infinity. So what do we know about the domain? All real numbers again. Okay. So again, as long as you have the idea, the fact that it's all real numbers. By the way, that's not a hashtag, is it? Not for me, right? Hello. Is Josh? Whose it is? Do you have your iPad, Josh?
It's in the office.
He just said it's in the office. Okay. Okay. Bye. They didn't know which of your siblings it belonged to, I guess. So anyways, it's in the office. Sounds like you knew that, though.
Yeah, I know.
Okay. Okay, so domain, all real, that's a number sign, yes? Before it was ever a hashtag on social media, it was a number sign. Got it? Did Mrs. Rogers tell you guys that too? X such that X is a real number, or in interval notation, negative infinity to positive infinity. What about the range? So range, what directions am I talking?
Up and down.
Up and down. So always start at the bottom first. How low does this graph go? Yeah. In other words, I want to know what's the y value there. And this ordered pair is 4, 0. So what's the y value? Okay, it goes as low as 0. How high does it go? Infinity. So what did you just write? Did you just write interval notation?
Yeah.
0 to infinity. Infinity always uses parentheses. Does this graph go through the point 0? It does. It goes through the point 40. So we're going to use a bracket there. Now, in terms of an inequality, it's going to be y such that y is what? Greater than or equal to 0. Because the graph started at a low of 0, goes up to infinity. Can I make it through the last one or not? Well, okay. What do we have over here? Another parabola. How do I know it's a parabola? There's an x squared, yes? That tells me it's a parabola. Domain, what am I going to ask you? How far? Left and right. How far left and right does a parabola go?
Infinity.
It goes infinitely. So this is all real numbers, or negative infinity to positive infinity. That should be becoming old news. Of course, you'll forget it all overnight, but confidence, the notes will help you remember. Okay, range. This is the one I wanted to get to real quick. Range is how high and low, right? It's up and down. How low does this graph go? It goes infinitely down. What is that infinite down below called?
Negative.
Negative infinity. So it goes down to negative infinity. How high does my graph go? No.
4.5.
It is 4.5. Sorry, it's a trick question, I guess. But you got the idea. You were in the ballpark. You just had to figure out the number. So it goes from negative infinity to 4.5. Negative infinities always use parentheses. 4.5 touches that. I'm going to use a bracket. In terms of an inequality, y such that this time y is not greater than a number, it is less than. So less than or equal to 4.5. Okay, sorry about that, guys. Hold on to these notes. Don't lose them. You'll regret that. Tomorrow, We will finish notes. We'll talk about Desmos. I'll get you set up for Savas. Hopefully this can all happen within one class period. Okay? So iPads and notes with you for sure tomorrow. Please, please, please. And I honestly feel like we did the harder part of the lesson today, so.